Okay, so we are going to start the interpolations. And in the syllabus, you have three types. Okay, the first is Lagrange. Second one is a Newton divided difference. Okay, and then the third is a cubic spline. So today we are going to focus on the Lagrange interpolations. And then you may wondering what is interpolations. Huh? Okay, let's say given a set of experimental data, okay, you need to approximation an intermediate fxk. You have the experimental data. Let's say, okay, you will have your, okay, you have is actually your y equal y. You know that y is equal to a function of fx. Okay, and for example, let's say from your experiment, you have your xy data. Okay, this is general. Let's say x naught, fx naught mean you have, okay, when maybe, okay, you have here I to indicate the position of your data. I is 0, 1, 2, 3, okay, up to you have the n data. So, okay, this position, so is x naught. Since y equal to, I put it is y equal to fx. That's why this one you have, let's say x naught f, okay, x naught, okay, this is x1, fx1, up to, let's say, xn, fxn. Okay, and okay, if more specifically, this one general, you have the point, okay, x naught, fx naught, x1, fx1, up to xn, fxn. Okay, maybe too general, you cannot understand what is fxk here. Okay, I put it specific k value. Let's say you have a specific value. Okay, for example, you have, okay, let's say when x is 2, 4, 6, 8, maybe this one 10, your y. Maybe this 35, something like that. Okay, for example, you have a data, okay, 2, 4, 6, 8, maybe the last data here is 10. You have 5, let's say this one, this case, you have up to, okay, 5 data, the n, the I, because we calculate starting from 0, so the n ending at 4. So you have, okay, 2, 4, 6, 8, 10, and then the y, corresponding y, 5, 10, 18, 27, 35. Now, okay, let's say given x equal to maybe 5, 7, given x equal to 7, okay, you want to estimate what is the value of y. So you couldn't read directly from your table because you don't you don't take the value when x is 7. So you cannot read directly. You have if you want when x is 2, you know y is 5. 4 corresponding to 6, 10, 6 corresponding to 18. Okay, how about when x is 7? What is the value of y? So you just know your x equal to 7 between 6 and 8. So you are going to estimate their value. Okay, the y values between 18 and 27 here. So this is the idea of interpolation. So means the value that the value of y that you are going to estimate must be inside the range of your list. So because 7 still inside 2 to 10, so you can estimate the corresponding y value. Okay, if you want to estimate, let's say when x is 11. Okay, x 11, so outside of the list. Even though you can just plug in to get the value, but it's not accurate. The meaning interpolation. So make sure the y value that you are going to estimate is inside the range of the list given here. So here, if the x is given from x naught up to xn, so you can only estimate and fxk value contained inside x naught to xn. So for example here, x equal to 7. So how to estimate the value of y? First, we can construct the polynomial of degree n. To construct polynomial means, let's say your point is x naught, fx naught, x1, fx1 up to xn, fxn. Okay, you make it, okay, polynomial of degree n, okay, is a curve. So you make it, you connect it. So you get this polynomial. So once you get polynomial, then given any value of x, you will know what is a, because this is actually y equal to pnx. So plug in any value of x, then you can get the y. So even though I said here, plug in any value of x, but if the x that you are going to mean you plug in the x which is outside of the range, so of course it's not accurate, because it will be accurate if your x that you are going the value of y that you are going to estimate, provided that the x inside the range from x naught to xn. So mean interpolation, first you can get a polynomial of degree n, and then you can estimate the intermediate fxk value. Before we proceed to the formula for Lagrange, do you have any questions here? If no, hold on. If no, we'll move to the formula. Formulation for Lagrange interpolation. So we are going to Lagrange the interpolation. You can get the polynomial of degree n. Hence, actually the y is equal to fx. Y equal to a function of x, and the function of x can be estimated by polynomial of degree n. Such that is actually this is a general formula for Lagrange interpolation. Is summation of Lix fi, or you can just simplify as Li multiplied by fi. F is actually your y. And then the Li is actually, this is a product, meaning of the product of x minus xj divided by xi minus xj, where when you estimate Li here, j cannot be equal to I. Meaning if j equal to I, later on you have a division 0. Mean x if j equal to I, then xi minus xj you divide by 0. That's why the denominator, and you observe the formula, numerator is x minus xj. So for example, just now you want to estimate what is a y value when x is 7. So you plug in x7 here. So what is xj? What is xi? And then just now you see the data that we denote like this. You have an I here, right? And this is I. Let's say you have only 2 data. If you connect only 2 data like just now problem, you want to estimate what is the value of y when x is 7. So you may just take 2 data, 6 and 8. 6 and 8, then you only take 2 data. So the approximation is actually linear. You take you take only 2 points. Then what you obtain is actually where's my where is it? This one. So when you take only 2 points, you'll get polynomial of degree 1, p1x. So just now you want to estimate 7. So you may take 6, 8, 10, or you take 4, 6, 8. As long as the 7 contain inside that 3 point. Here. So you have here 1, 2, 3. So this is you will obtain polynomial of degree 2. Degree 2, so it will be the quadratic approximation. I want to move back here. Then if you move to this problem, so if one estimate x equal to 7, you take 6 and 8, 6 and 8 here. So this is a linear approximation. And then if you take 3 points, you may take 4, 6, 8. So 7 still inside the list. So this is quadratic, or you may take 6, 8, 10. So also okay inside the list. So of course, if you take 4, 6, 8 or 6, 8, 10, the answer will be different. But you cannot take it for quadratics. You take 3 points, but of course you cannot take 2, 4, 6 because 7 is outside of the list. So you here in this case you got two choice, either take 4, 6, 8, 6, 8, 10 for quadratic approximation. Okay, so now for linear approximation, how to get that polynomial of degree 1 here. I mean, if you want to get the polynomial of degree 1 for Lagrange interpolation, you have the L nodes F node plus L1 F1. So how to get your L nodes? Okay, so you have here back. For linear, you take only 2 points. Make sure that 2 points, the y that you are going to estimate contained in that 2 points. So let's say this is x node, this is a x1, then this is a f. So this is your f node, f1. So to calculate your L node is actually, meaning of this notation is actually when you want to calculate L node, so this will be x node. So you have x node. Since I cannot be equal to z, so you x node minus x1. X node minus x1. And then the numerator, x node, you just replace by x. Numerator and the denominator, almost same except here. This is x. So for the just now example, you can plug in x is 7. X is 7 here. And then plug in corresponding x node, x1 value, f node. And then for L1, this will be x1. This is x1. And then, x1, if this is 1, so this point cannot be x1. If x1 minus x1, then you have division 0 problem. So that's why x1 minus x node. And numerator, this will be x minus x node. This is for linear approximation, where you can get straight line. If you want to get the polynomial, then you cannot plug in the x. You expand, you simplify, you will get polynomial of degree n, degree 1, which is linear. But if you want to estimate what is the y value, then you can straight away plug in the x here. And then why I said this is a product, the product form. When you have three data, let's say add in one more data, so this will be x2, this will be f2. Then, this one, compared to the L node in linear approximation, you have, if P2x, here will be 2 term, product of 2 term, this one 2 term, and if P2x, L node, F node plus L1, F1 plus L2, F2, this one you have extra term. So you compare the linear and the quadratic, you will see, you have the extra term, the third term, which is L2, F2, and the L1, L node and L1 also extra here. That's why this symbol stands for product. And depends on the whether you have linear, quadratic, cubic, and higher order approximation. So now if quadratic, how do you get the L nodes here? When L node, so you notice a denominator here this is x node. The first term here, same with a linear, same with the linear approximation, only the second term, when L node, so the x minus the other 2 points not from x node. So that's why x node minus x1 multiply x node minus x2. So numerator x node here you replace by x. So for L1, you extra this term, x minus x2, x1 minus x2. So you notice when x1, you cannot minus, cannot x1 minus x1. It's only x1 minus x node, x1 minus x2. For L2, you are in here, L2. So the x minus x node, x minus x1 here. So numerator x2 here, okay, if I start from numerator, so x minus x naught, x minus x1, and then denominator you replace the x by x2. So you compare the linear and quadratic first. Okay, and for this Lagrange interpolation is not iterative calculation. Like the Gauss elimination method is not iterative, meaning you got a few 3 steps for linear system of 3 by 3. LU only LU factorization method also 3 steps. That is not iterative methods. This one also mean you can just plug in everything accordingly to the formula, then you can obtain the answer. If you have no question, we proceed. So this one you see linear approximation, you get straight line, so it's a linear. 3 point, you get quadratic. Then this is a cubic quantic. So you see the term. You have more term here. So for cubic is P3x. So L naught F naught plus L1 F1 plus L2 F2 plus L3 F3. So if fourth order, add up one more term, L4 F4. So for each L naught, L1, L2, L3, if cubic, so you have a product of 3 terms here. So for L naught, it's actually as if I start from denominator, for L naught, you cannot x naught cannot minus from the point with x naught. So you minus with x1, minus with x2, minus with x3. And then numerator, you just change x naught to x. For L1, similarly, will be x1 minus the point not from number 1. So x1 minus x naught, x1 you minus x2, x1 you minus x3. Then numerator, you replace back all the x1 here by x. And then for L2, L2 will be x2 minus the point not from number 2. So minus x naught minus x1 minus x3. For numerator, you replace all the x2 here by x. For L3, so it's x3 minus the point not from number 3. So minus x naught minus x1 minus x2. And then you replace x3 here by x in the numerator. So the same concept can be extended to fourth order approximations. Do we have any question here before we go to the example?
Excuse me, doctor.
Yes.
In the final exam, in the paper, is it have a formula or not?
Normally, we won't expand for you too long. They give this form. The first line here. Fx is approximated by Pnx. They give this summation form. Then the Li product of x minus xj divided by xi minus xj. Then you have to expand yourself. Because it give you too long. I mean, we give you general one, you expand yourself.
Doctor, thank you.
Thank you. So you have to understand, what is this meaning here? This symbol stands for product, so you have to expand yourself. So make sure you write down the correct formula. If not only correct formula, for Lagrange, the problem is, the formula is straightforward but tedious to calculate. And then, in the YouTube video that I gave to you in the author and the Telegram, is actually, I calculate using the spreadsheet menu in the, the latest model of the Casio, which is a classic model, FX570EX, using the spreadsheet menu. However, that model, is actually they try to copy the idea of Excel, but they have limitation only 5 columns and 45 rows. So that's why not all the numerical method. If you have more than 5 columns, for example, by section method, then not suitable to use that calculator to do it. So this formula, same with what written on the books is not only that classic model, any model you can use this technique. Mean here this one is actually calculate each Li multiplied with Yi, and this for the fourth order approximation. Mean this is for the fourth order approximation, so mean this is a Li Yi. So fourth order, you see back the formula here, 1, 2, 3, 4. Quite tedious to calculate one by one. You tend to calculate wrongly. So this is just a quick tips, but not using the spreadsheet menu in the calculator. So the formula actually for fourth order, remember you have, let's say I just put up for L notes. L note you have the formula is x minus, for fourth order, this formula is for fourth order approximation. So you have x minus the point not from 0. Mean you want to derive the formula is very easy. For fourth order you have 1, 2, 3, 4. Four product here. So L naught x minus the point not from 0. So minus x1, x minus x2, x minus x3, x minus x number 4. And then denominator, just replace x by x naught when you have a L naught. So but behind, just follow. This is only L naught. And then here x tally with this x here. Mean given what is the x value, then you are going to estimate what is the corresponding y value. So this is all here. This is x. The a here, a is actually stand for your x naught. Mean if in general, if you have the Li, let's say this is Li, then mean this one is all the I. A is actually the current x value. A is a current x value. Sorry, this one got wrong. This should be A. So A is actually when the L notes, this is x naught. When L1 will be x1. So A is actually the current x value. B, C, D, E are not from xi. I mean, if your current x is x naught, so B, C, D, E are not from the x naught. Means later on you will have like this I. Then this is, let's say I0, 1, 2, 3. For fourth order, you have up to 4, 5 point. Cause 2 point, you get linear. 3 point, second order, quadratic. Fourth order up to 3, up to 4. And then this one is a x. This is a y, f. So x naught, x1, x2, x number 3, x number 4. So when you are standing at the column I equal to 0, A will be your x naught. And then B, C, D, E will be the other point, x1, x2, x3, x4. The Y will be the same column here. This will mean when you are standing in this column, X is actually the current X value, Y is the current Y value. Sorry, X is given the X value, A is a current X, Y is a Y here. Then B, C, D, E are not the current X value. So when you are moving to column 1, A will be your X1. Then B change to your X naught. The other one B, C, D, B, C, D, E still the same, and Y move to here. Maybe you have to use the specific example, then you can understand better. Let's say here, given this data which is generated by the function y equal to ln x, this one is actually well-defined problem question. because we want to compare which approximation is the best lah. Linear, quadratic, cubic up to third order. So since you have the exact solution, why we have exact solution? Because this y or this data is tabulated by the function y equal to ln x. You want to approximate f 4.5. F 4.5. So of course, if you know the function, you can straight away plug in x is 4.5. Then you can get the y equal to ln 4.5, which is 1.5041. So this is an exact solution. If we know the function, you can easily know any y value that you are going to estimate. But in the real situation, you don't know the function. That's why we need the interpolation technique. But this question, we give you the known functions so that we want to compare their errors to know whether linear is better or linear, quadratic, and cubic, which one is the best for this example. And then using linear, so 4.5 is contained in 4 and 5. So make sure you take the last two data. Don't take 3 and 4 because 4 outside. Also cannot take 2, 3. 1, 2 cannot. You can only take 4 and 5. So that 4.5 inside. 4.5 will be inside the list, or the range of 4 and 5. Is it clear how to take the data? So make sure you take the last two so that 4.5 inside. Don't take 1, 2, don't take 2, 3, don't take 3, 4. So for linear, you move here. If you plug into the formula accordingly, you calculate, you'll get this value. For linear, maybe you can straight away calculate, no problem. So mean linear, make sure you take 4 and 5. So this is, this one is your x naught. This is your x1. So this is your f naught. This is the f1. So this is L naught, F naught, L1, F1. L naught. Then how you show you how to use a calculator. This one is straight away you plug in everything to the formula. I want to use a calculator. So in this case, even though this is linear, actually you can calculate in one step. But just to show you, if you want to put it into the shortcut, you may put in. You will calculate your Li. This is calculate Li Fi using the formula x minus b a minus b multiply y. I will calculate this each term result here using x minus b a minus b y. So when you are standing at column I equal to 0, this will be your a. This will be your b. This is the y. So put in the formula. Sorry, I don't need it. I need x minus b, and then I will have a minus b multiplied by y. Let me put up here. There's a y here. So I key in the formula as x minus b, a minus b multiplied by y. And I calculate this term here. So you calculate, they'll ask you what is the x value. So given, we want to estimate what is f 4.5. F 4.5 means x is 4.5. Because this one yesterday I show for section 4. So the value is still there. So to accept the value, I just go down, B. Okay, when you're in column I equal to 0, B are not, okay, B are the X value not from this column. So B will be 5. Okay, then you equal A. A is the current X value, 4. Y. Y is the current Y value, 1.3863. Because this is actually Y equal Fx. And you equal. So show you this Y value equal one more time. So you get 0.6932. And then the second term L1, F1. Okay. For second term, you move to here. So this will be the A, this will be the B, this will be your Y. So you calculate again. A, they will ask X still same, so to accept, press down. Okay, B. B, okay, you are in column, okay, I equal to 1, so B is not from, okay, B is an X, not from this column, so will be 4. So equal, A is a current X value, which is 5, equal, Y, okay, is a current Y value, is 1.6094. So you get here, then you add up, you get this result. So of course, we'll be tally, you will calculate one line. For linear, okay, approximation, okay, if you want to calculate in one line, you still can, okay, possible. But okay, when you have up to polynomial degree 4, you appreciate, okay, using this formula will be, okay, much, okay, easier. Okay, before you proceed to the quadratic, do you have any question that you want to ask?
Excuse me, Doctor.
Yes.
If the question asking the 3.5, is it the same concept we using for this question?
Yes. If you want 3.5, so you make sure don't take 4 and 5. If you want to estimate F 3.5, and then if you want to use linear approximation, then you take 3 and 4. Then the same concept, you just change the data. Mean, okay, if 3.5, now you focus on these two data. So this will be, mean, okay, this one is your X naught, this is your X1. This is a F naught, F1. Mean only the data change, the concept, the formula still same. Okay, if 3.5, you change the data 3, 4. And then your corresponding Y naught, okay, Y1, still the same formula, only the data change, the answer change. So that's why, okay, if this question, okay, estimate 4.5, you take 1 and 2, you still can get the answer, but it's not correct. It's because you use 1, 2 to estimate. Your data is here, 4.5 is here. So of course, you have a lot of error, not accurate. So make sure you take the correct, okay, range of data. Otherwise, your answer will be not correct, not accurate. Okay, and then quadratic. Okay, if quadratic, as I said, okay, 4.5 inside here. This is 4.5. So you can take, so this question, you only one choice, to take 3, 4, 5. If you take 2, 3, 4 wrong, because outside, 1, 2, 3 also wrong. So you can only take 3, 4, 5. Okay, so 3, 4, 5. So now, for quadratic, okay, I will use a formula. Okay, before you see how you calculate it, look at a big one first. Okay, manually you will calculate. This is a L naught, F naught, L1, F1, L2, F2. Plug in all the corresponding value. Okay, why we indicate 0, 1, 2? So this is X naught, X1, X2. This is your F naught, F1, F2. Or you want Y naught also can, because Y equal to Fx. Okay, or F naught is actually equal to Y naught. So this Y1, Y2 are the same. So this is calculate manually, plug in. Okay, X is 4.5 because you want to estimate F 4.5. X will be 4.5. Okay, Then you plug in all the corresponding value x0, x1, x2. This is f0, f1, f2 in the quadratic Lagrange interpolation formula. You calculate, okay, as usual, you will get this answer. Okay, now I'm going to show, okay, how you can calculate, okay, this how to okay, to make it to calculate quickly and accurately using the shortcut. But this one without using the spreadsheet menu. If you want the spreadsheet menu, you can refer back the YouTube video that I gave to you. Okay, so for quadratic, okay, we'll calculate the LIYI as, okay, still same, x minus, okay, b is not from xi, so quadratic you have second order, so two terms, so x minus c. Okay, and then this will be a is a xi. So when you point to I equal to 0, a will be 3. Then bc will be, this will be b, this will be c. So mean when you are standing here, this is a, this is b, this is c, this is the y, x is given from the equation 4.5. So x, a minus b, a minus c multiplied by y. Okay, I cannot show the calculator in this view, in this presentation mode. I have to end show. Keep it. Okay, so now, okay, from the linear, I can just extend the formula. Bracket, go up. I have to bracket because the product of another term. So bracket it, x minus c. Okay, go down. You have a minus c, like this. So this is for quadratic. So you see, extend, okay, one more term, quadratic. So total, okay, numerator 2 term, denominator 2 term. Okay, you calculate x 4.5 because we key in just now, previously we have already. So to accept, press down key. B. Okay, you are going to calculate standing at I equal to 0. You want to calculate the first result here, L naught, F naught. So okay, B not from the current X column. So B is 4. Because this one from previous calculation is there. So to accept, you press down. C. C is here. This one 5. Then equal. Okay, asking A. A is a current X value. So A is 3. Okay, then you equal. Asking Y. Okay, Y is a current Y value. 1.0986. Okay, so one more time equal. So you get negative 0.1373. So this is manual calculation. You plug in, you calculate everything you get here. Then this is using this formula, x minus b times x minus c divided a minus b, a minus c. Now move to second column. Okay, now you move to here. Okay, when you move to here, a will move to here. A is a current x value. Okay, so you swap, change position of a and b. So a move to here, then b will be this one. Okay, y also move. Okay, so can you understand? Okay, y is a current y value, x is a current x. Okay, so BC will be the other x. So initially, first time you A here, B here. Second round, swap A and B. Y move. Okay, is it okay? Then if okay, we calculate x. Okay, still same. So press down. B. Okay, B change to 3. So key in 3 equal. C still same. So just press down. A change to 4. Okay, Y change to 1.3863. Oh, make sure you key in correct. 3863. Okay, so equal one more time. You get 1.0397. Is it okay? For this technique, okay, not only this model, ES plus also can. MS, you cannot see the natural display. So make sure your bracket. If you use MS, denominator, make sure you add in one more bracket. If you use MS, make sure you add in one more bracket. Otherwise, you only divide this one, A minus B. This will become multiply. Okay, if okay, then we move to, now we move to the third result. The third column. Okay, if the third column, okay, A is a current X. So A move to here. So you swap A and C. So A move to here. A is a current X. Y is a current Y. So this one moving. So this will become C. So mean third time you swap A and C. Okay, then you calculate again. X still same. So you press down. B maintain 3. So press down. Okay, C now become 4 equal. A now become 5 equal. Y now become 1.6094. Okay, equal one more time. You get 0.6035. Then you add up these three answers, you get 1.5059. Okay, and just now I forgot to calculate the question 1, the absolute error. So this is absolute error. This notation, the epsilon is the error. Or just put E also can. So absolute magnitude. Okay, you can either exact minus approximate or approximate minus exact. The exact is 1.5041. So you minus approximate, taking the absolute value, this one you get 0.0018. Okay, just now linear, the absolute error is 0.0062. So you see quadratic, the error reduced to 0.0018. This one is quadratic. Okay, is it okay? Can you follow?
Yes, doctor.
Okay, yes, then we move to quadratic. Okay, it's like cubic. So cubic, just now linear, take 4 and 5. Quadratic 3, 4, 5. Cubic 2, 3, 4, 5. So that 4.5 contained in the range. But don't take 1, 2, 3, 4. 1, 2, 3, 4. 4.5 is outside of the range. So you only can take 2, 3, 4, 5. So this is a cubic. Okay, if you those who take the notes earlier, the last two rows are wrong. Got calculation mistake. Only realize is during the section 4 class. So make sure if you already downloaded the notes, see the last two row value. This one is the latest. If the last if you only downloaded last night, then will be correct one. If you download it before that, that one is the last two row contain error, wrong calculations. And see the error reduce. Just now the this is a quadratic 0.0018. This is 0.0015 reduce. So the best one is a cubic for this example. Okay, then how to calculate here quickly? The same thing, I'm going to put up the formula Li Fi. For cubic, mean is a polynomial of degree 3. Cubic is P3x. P3x. Then you have x minus b. When you're standing here, this is A, then this will be B, this will be your C, this will be your D, this will be your Y. So x minus C, x minus D divided, A is a current x, so A minus B, A minus C, A minus D multiply the Y. So this one, if manually, you write down this formula, then you plug in all the x node, x1, x2, x3, f node, f1, f2, f3. You calculate everything manually. Lastly, the answer is 1.5026. Okay. I'm going to show you. Okay, how are you going to, okay. So if cubic, okay, use back the formula, just add up one more term at each numerator and denominator. So will be x minus d. And then go down, will be a minus d. And then calculate. So the same concept, okay, x still 4.5, go down. B is 3 or a half, so I go down. C is 4 or a half. Okay, D is here 5. Equal. A is here. A is a current x, which is 2. Okay, Y is a current y, which is 0.6931. So you get 0.0433. So this is the first term, L naught, F naught. Okay, the first term here, L naught, F naught. You get, okay, 0.0433. And then now I'm going to calculate L1, F1. Okay, for L1, F1, okay, you move to the second column. So this will be the A, swap A and B. So A is now here, Y now here. Swap A and B. C and D just maintain maintain their value. So you calculate again. X still 4.5, so press down. Okay, B swap to 3. B swap to 2. So you can, okay, on the paper, so okay, whatever that you swap, so you just, okay, cancel it so that you won't key in wrongly. B is 2. C still same. Then down. D still same. Down. A is 3. A is 3. Y is 1.0986. So you get negative 0.3433. Okay, is it okay? So we'll calculate now L1, F1. So later on, we are going to calculate here. And calculate the L2, F2. Okay, the L2, F2. So you move to here. So A is a current position of your X. So you have A. B still maintain, so C become here. So swap, okay, A and C. Because now A move to, okay, third column, so C will move to here. Y now here. And you do not confuse, you can erase, erase here. So in the third column, A is 4. So this is B, this is C, this is D, Y is here. Okay, calculate again. X same. Okay, if same, don't press equal. You equal, then you mean you take up all the previous result. Go down. Okay, B still 2. Don't equal. Equal, then you will, okay, so if you equal straight away, you give still this result. So X 4.5, B 2. Okay, if you accept this value, go down to C. C now is going to change to 3. Okay, only once you input the new value, you equal. Okay, D still same, so press down. A change to 4. Equal. Okay, Y have to change 1.3x63. Then equal. Equal. So you get 1.2997. So you have calculated now until L2, F2. Okay, left the last result. Okay, last result. Okay, we're moving to here. So we're moving to the fourth column. So A here, Y will be here. So BC is maintained. So this will be D. In the last result, A is here. So B, C, D. So you calculate X 4.5, press down, B2, C3, go down, D become 4 equal, A become 5 equal, Y become 1.6094 equal, okay, 0.5029. Then you add up these four value, you get 1.5026. Okay, let's say add 0.0433 minus 0.3433 plus 1.2997. So 1.5026. The exact value is, so if I take, this is approximate minus 1.5041 exact. Okay, make absolute value, takes a positive value, so become 0.0015. Okay, this is up to cubic approximation. Okay, if up to fourth order, you can try add up, let's say X minus E, A minus E. So do you have any question? This is using calculator without using the spreadsheet menu. Okay, this one, okay, like the Excel, but you have limitation. Okay, 5 column. Okay, to copy this one, not like Excel, you can drag. This one you have to go to, okay, press the option, find the copy. And it's too small compared to you use a computer in. Okay, and then if you no question, okay, I will can continue a bit. Okay, just show for Excel. I just showed directly that one using up to the cubic approximation, and then we know the function is actually tabulated using y equal to ln x. So I can key in equal, and then to tally with the the value that is 4 decimal place, I round. The function is ln. Okay, so ln, you see, you open close bracket. So this is a x. Okay, I want to round it 4 decimal place. So I get exactly only 4 decimal place. If I don't round it, you have contains all the decimal place. Because I want to compare with the calculation using calculator just now. Okay, now I want the cubic approximations. So I will calculate in this way. This is L, and then this is a F 4.5. So in this cell, I calculate only L nodes. I calculate this one only. I calculate only L nodes. Okay, in calculator just now, I straight away L node, F node already. Okay, here I just calculate. In Excel here, I only calculate this cell is L node. So mean here L node, L1, L2, L3. Okay, and then you see the formula. L node is x minus the point node from x node. So x minus, and then P3x, so total you got 3, multiplied by 3 term. X minus x1, x minus x2, x minus x3. And then denominator replace the x by x node. Then for in Excel, make sure the denominator here extra bracket. If not, they only divide this term. These two terms will become multiplications. Okay, so similarly, if you understand that formula, you can just easily key in into your Excel. So the bracket x that we are going to estimate, given x is 4.5, so I put it x 4.5 minus, okay, click location x1 here. So multiply in Excel, okay, press the star there. Then 4.5 minus x, okay, x2. Click location of your x2. Okay, multiply 4.5 minus x number 3. Okay, divide backslash. Okay, denominator put bracket first like this. Okay, later on, you see numerator and denominator almost same value, only x replaced by x naught. So I'm lazy to key in. I will highlight numerator term and then press Ctrl C, put inside the bracket Ctrl V. Okay, later on select 4.5, click back to location of x naught. 4.5, click location of x naught, 4.5 location of x naught. Okay, you enter. Okay, this is only L naught. Okay, this value is already L naught multiply F naught. So okay, the value, okay, intermediate process here different. Here I only calculate L naught, okay, only. And then now what I'm going to do is actually I'm going to copy the formula, but copy one by one only. The techniques, the tips here, copy one by one. So copy to here. Then you see here. Okay, when you copy, it's actually initially your formula you key in Excel is actually just now you key in x, you key in 4.5. Okay, x1. Okay, where is it? X1? X1 in cell. Okay, in location D3. D3. Okay, this is D3. So this is E3, F3. Okay, and then X naught is in C3, D3. So C3, E3. This is C3, E3. 4.5. When you copy 4.5, we maintain 4.5. Okay, is in Excel when you copy to the next column, D will become E. You see, D become E, E become F, F become G, which is actually wrong. Okay, which is actually wrong. Mean, okay, according to the formula, before I show you, mean, okay, the L naught formula just now you key into Excel is actually 4.5 minus, okay, x1 in D3, D3, 4.5 minus E3, 4.5 minus F3, F3, and then you divide it by, okay, like this. This is C3 minus D3, C3 minus E3, okay, C3 minus F3. Okay, of course in Excel make sure the star there stand for the multiplication. Cannot. Sometime. Okay, and then when you copy, because of relative, okay, concept, when you copy constant become constant, D will become E. E become F. Mean the D formula move to next column. So D become E, E become F. Okay. And then F become G. Okay. F become G. So C become D. So this is E, this is D, this is F, then this is D, G. That's why when you click, okay, this formula, you see, it moved to column G, which is wrong, which is actually wrong. Okay, and then when you check back, okay, suppose the formula that you, okay, if you key in manually, then the X naught, okay, if X1 start from D, E, F, X naught will be, this will be C, yeah? This one should be C3, okay, and then C, C, D, E. So this is E, this is F. If X naught start from C, X1 will be D column, so C, E, F. So this will be, okay, so this is D. Okay, mean D3 minus E3, D3 minus E3. So you compare with the formula that you copied, you have, okay, you have E and F, right? E, F is correct. Okay, you see bottom D, D3, D is correct. Okay, only the G is wrong. G you should tally with the C, which is actually X naught. So mean in shortcut, okay, if you can understand, okay, how Excel copy, okay, if not, mean, okay, make sure you key in the L naught formula correctly. Make sure you key in correctly according to the formula. You copy it to L1 one by one slowly. If you copy it straight away, different story. You are confused. Huh? And then you kick back the formula. Okay, actually G is wrong. Okay, you always drag, okay, to X naught back. How you drag? Point to the, okay, top, okay, or point to the border. Click and hold down your mouse to drag it to X naught. So later on your formula will be always correct because of relative column. When you copy D, move to E, E move to F, F move to G, the G is wrong. Always drag to your X naught because of this reason. Okay. And then from L, okay, once L1 correct, you copy it to here. So if you cannot drag, okay, you just edit G column to C. So the formula G you change to C. G you change to C. G here you change to C. So this is the, okay, L2. Then you copy to get the L3. Okay, and then you either you drag, okay, or you change, okay, edit to the formula. Okay. And then lastly, your answer is actually L naught multiply F naught plus L1 multiply F1 plus L2 multiply F2 plus L3 multiply F3. So you get the same answer with what you obtained here, 1.5026. So okay, in that previous case, the YouTube, okay, that I show using this case spreadsheet mode, okay, similar, okay, it's actually similar concept here, but to copy in calculator is not as easy as you copy in Excel here, using the same technique. Mean, okay, just make sure you key in the L naught formula correct. You copy to here, just edit the wrong formula. Okay, always. Okay, when you copy it will always move, okay, to G. G you always drag back to the X naught column here. So this is, okay, using the Excel. Okay, and Excel, okay, if the formula is done, if you want to make it more general, so the X 4.5, okay, you can key in into another location. For example, okay, let's say I put, okay, to make it as a template, then my formula, okay, 4.5 here, I can make it as a constant. Okay, and then on. Okay, I copy again. Now this one, drag it, then okay, the technique here provided you copy one by one. And then okay, let's say I want to estimate, just now you said you want 3.5, yeah? Okay, since 3.5 still inside the range, so I can estimate 3.5. This is what I get. Okay, I can check with the exact. Okay, exact, this is actually ln. Let's say ln this cell, make it as constant so that I can change any value, but provided the value that I'm going to estimate is inside the list. Then I can find the error. ABS, okay, the exact minus approximate. So if I change back, okay, 4.5. Okay. So let's say, okay, if let's say I said, if you put 5.2, you still can get the value, but it's actually outside the range. So it's better, let's say, okay, the value that you are going to estimate inside the list. Let's say 2.5, 2.5. So, okay, this one, to make constant, is actually dollar in front and at the back of the column label. Means fix the column. Dollar in front, okay, C, that means fix the column. Okay, and then behind is actually mean fix column C, fix column 1, so that when you copy the formula still maintain like a constant, like what just now I key in 4.5. If I key in 4.5, later on I want to change to 2.5, then I have to change the L0, L1, L2, L3 formula. So if I put this way, then I can just change my X that I'm going to estimate. Then everything automatically change. Okay, I want, let's say, 3.8. So this is like, you don't need any programming, just key in the formula. So it's like the auto template. You just change and value, but make sure the value that you change contain inside the list. You already 9:20. Okay, do you have any questions? Okay, so if no, I'm going to stop this Lagrange already 9:20. We have maybe break 5 minutes. 5 minutes, and then we continue the tutorial for exercise 2.